Looks good. Awesome. I figured that I haven't spoken at an event since pre-COVID but I had a beer now, so I'm not as nervous as I would be. Um, so I want to talk about distributed tracing and OpenTelemetry here. My name is Daniel Kahn. And after I did the slides, I added that one, and this does not work either. So I'm doing that one. Yeah. I added this slide because that's a storyteller a little bit, because I feel a little bit like that when I now go back in history and tell anecdotes about various stations, basically, of what I did or what I watched in the first row the last few years. There will be no dragons in my talk still, but hopefully a few, I don't know, interesting insights in all of that. And to start this out, I want to talk real briefly about me, because the stations that I went through more or less explain basically what I talk about in this talk. So I'm living in the Mühlviertel. I have 4 kids. I live there with my partner, and we have a puppy since last Friday. And that's the puppy. So super, extremely cute until you have to take it out at 4 in the morning. So there are always pros and cons to everything. So I was at Dynatrace from 2015 to 2021, and I was there. So I'm an engineer by trade, actually, but then I got on the wrong track, and then I got into technology strategy and also product management stuff. So there, basically, my journey into observability started, more or less. Then I also started to do courses on LinkedIn Learning about Node.js, about microservices and all that stuff. So I'm still doing that. At some point, it happened to me that I became co-chair of W3C Distributed Tracing. I did this 2 years, but I was in this group for a longer time. I don't know, W3C, does this ring a bell for anyone except this W3C like checker that you had back then in the days, right? When you checked the quality of a website, but they do way more than that. And I will talk about this briefly later. Then I joined Elastic, was there for a year as a director of product management, worked in unified observability. And since 2022, I'm director of product management for telemetry at Sentry. I don't know, does show of hands, Sentry, who knows it? Oh, wow. Yeah, it's always amazing. It's pretty cool. So I did not know them really before I joined them, I have to say. But when I started at Dynatrace back then, no one knew Dynatrace, even in Linz. That was also fun. I don't know, observability, OpenTelemetry, show of hands. Who knows OpenTelemetry? Plenty. Who uses it? Just a few. Yeah, that's what I'm always seeing. Yeah. So I want to explain or give a little bit of a pragmatic guide to OpenTelemetry, because as we know, we engineers like shiny new things. OpenTelemetry was and is pretty shiny, and I think it makes sense to understand where it came from and what you can do with it, and maybe also what you can't. So I start with a very super brief history of distributed tracing, because interestingly, when I started, also what I have to say, at each company where I joined, I was basically then at some point the OpenTelemetry guy that implemented or made OpenTelemetry happen in this company, because they all were observability companies, and it kind of happened to me then that I always got this role, and so whatever. So we all know, and this was basically around 2014, 2015. The world was still pretty easy because no one had invented microservices yet. We were done with SOAP and all that stuff, which was also a lot of pain in the ass, basically. It was. I mean, it really was. But then we had this time where people were having monoliths, everything was great, so everything was also easy, right? You basically had, when you wanted to debug something, it was enough to look into a log file, it was enough to attach a debugger, run this thing locally, and you were good. then we decided again to make things complicated by coming up with the concept of microservices. And I mean, that's the CNCF meetup, and everyone knows Kubernetes and all that. But this made things extremely complicated again, because suddenly all those little microservices were communicating with each other. And also, to make matters worse, we also got this, like all these external services like AWS, Google Cloud, Azure. So you suddenly had a lot of complexity again in your system. And what made it even more worse was suddenly you had again the wire, the network, as a component of your whole deployment. So there is a lot of stuff that can go wrong here. So, and everyone that works on microservices knows this basically. And then you end up in such situations where you see that, okay, we see that for some reason there are a lot of successful requests on the card service, but there are also quite a lot that have an error there. Yeah. And then you're asked about the status report. You're asked about what's wrong here now. And basically you just can, all you can say is, I have no idea. I just know that there are problems, yeah, but I don't know which problems there are. And this was the rise, basically, or this whole observability movement basically came from. Yeah. So we decided that we need a better way to understand how services are communicating with each other, to understand where a problem is coming from. For instance, if the card service here, and that slide is stolen from Dynatrace, but I put the source down there. So, not the slide, the picture. But when the card service fails, yeah, or each failure, basically, you see it first in the front end, and then someone calls you and says, hey, something is broken. Yeah, you don't know what. It can be anything. It can be the database. It can be the service itself, whatever it is. Yeah? And distributed tracing promises to give you a way to understand how things are communicating and where problems are coming from. So that's the basic idea of all of distributed tracing. And if we talk real quick about monitoring versus observability, because that's also a topic where people are fighting against, it's a little bit of philosophical thing. This here is monitoring. It tells you, okay, I know I have so and so many errors. Yeah, that's a monitoring thing. Observability tells you that those errors are coming from requests to the card service for the currency pounds or euros or whatever. Yeah, so you can understand those so-called unknown unknowns, problems that you did not anticipate that they would happen. So that's basically, in a nutshell, the difference between observability and monitoring. Yet, yeah, that's a lot of marketing also, a lot of fun. So how do you do this tracing thing? Basically, so you want to understand how requests traverses through a system. Easy. How could you do that? Basically, give this thing a context ID, right? So you just, when an HTTP request comes in, you give this thing some random ID, and then you have to take care of taking this ID from hop to hop. How do you do that? Usually by using the HTTP header for that. But if you have, for instance, here a queue, you have to find some other way. You have to find a way to add this context ID to the metadata that the queue supports. Yeah? And somewhere there, when you want to do tracing, of course, you have to send it also to some backend, to some tracing observability backend, be it Jaeger, be it Dynatrace, be it New Relic, whatever. Yeah. So, but with this ID, you can basically correlate all those things that are happening. And those things that are happening are called span. So a trace is basically nothing but a tree of spans. That's the whole concept of it. And now I'm going back in history because I have to explain that, because everyone thinks this was invented by basically through OpenTelemetry. This is super new, but it isn't. Yeah? So this whole thing, and this works. So this started very early, and Dynatrace was even earlier with their patent on tracing. But after 2010, around 2010, Ben Siegelman wrote the Dapper paper, and there he was working at Google, and he described more or less how to trace complex distributed systems. So there is a paper, you can find it online, you can read it. That's basically the foundation of a lot of things we are doing now. Then in 2012, Twitter were running a rather complex system, and they decided that they need some way to monitor it, and they built Zipkin. So Zipkin was an open source tracing, and still is, an open source tracing tool, which uses a header, and this header is called B3, and this is basically the header used to propagate the trace ID. And this B3 header is called like that because it's Twitter had the thing they named everything after birds. So in B3 header means Big Brother bird. So that's the anecdote to that. Then Kubernetes came along at some point. Around 2015, we had Jaeger emerging, and it was a project by Uber, actually. And then Lightstep came up with some open source way, an open source library, a definition that was called open tracing. So these were all already there at this point. And then in 2017, Open Census came along, which was from Google. Also an approach to create the open source library to enable this tracing that I just described. Each of them defined their own way to do things. Each of them defined their own headers. And about what came next, we will talk a little bit later. But OpenTelemetry and everything came then way later, around 2019. So this is the world we are right now. So we are, let's say we are in 2018. All of that already exists. Now, one problem that came up was, and there basically Dynatrace comes in, and my work at Dynatrace is, so what do we do in multi-vendor scenarios? So imagine there is a browser application that is monitored by Dynatrace. Then you have some API for the web server, which runs on Azure. And then again, you have Dynatrace. And suddenly, you cannot propagate this header through all those hops, because who says that Microsoft will pass on? So the Dynatrace header was called x-Dynatrace. So why should Azure suddenly start to propagate a x-Dynatrace header? No reason to do that, right? And this was then the reason why a few people came up with the idea, why don't we standardize this header? And this was, so still context there. And this was basically the inception of W3C distributed tracing, the working group. So some folks, and also my boss at Dynatrace, went to W3C, said, we want to make a working group where we want to standardize this header. We want to standardize how trace propagation works in distributed systems. And as you see down here, and this was from our meeting in Seattle, there were a lot of vendors: Microsoft, AWS, Google Cloud, Dynatrace, AppDynamics, New Relic, Lightstep. So a lot of companies came together and said, hey, we want to find a better way to collaborate. And that's pretty unique, right? And also the meetings were always pretty interesting, because you had people from the industry, everyone working pretty much in the same field. And we got together and just exchanged what we knew and built something that became a standard that looks like that then. So W3C is like the UN, basically. It's super complex to get anything done there. They have a lot of processes and deadlines, timelines for each step. Some like a specification goes through. But trace context became and is now the standard for distributing, for distributed tracing. So basically every system is using it today. There are also other things in W3C besides the trace header. For instance, you have baggage, which defines how to propagate userland, user space information, like for A/B testing, for instance. You can basically the baggage header basically ensures that for whichever system you use, it will be propagated, and you know from each hop which A/B test, for instance, this belongs to. And in a nutshell, this looks pretty much like that. So you have, for instance, this browser application which has a span ID, and you also have a trace ID, and with each hop you propagate first the trace ID, but also the parent ID, which is the span ID of the span that basically does the call. And with that, you can connect a trace and build like these nice waterfall charts that you know. There is a little bit more about this about the standard and a few more flags that are sent around, but this is basically it. That's the foundations is trace ID and the parent ID that gets propagated. And with that, for instance, let's say Azure, they do it in .NET. AWS, I don't know if they picked up on it already, but all vendors and also the cloud vendors try to really, when they see this header, try to propagate that through their API gateway, wherever they see that. So the goal is to get something like that, right? So now we have this trace ID, and we are propagating it, and this falls out on the other end. It's like magic, right? Problem is, no, it's not, because what you now have to do is you also have to make sure in your applications that this trace ID gets propagated. Means that with each outbound call, you have to inject this trace ID, and with each inbound call, you have to extract this trace ID. Means you have to basically, if you think about the most complicated case, a Node application, who knows Node? Where you have basically one single process, you have to find a way to propagate this ID through all the calls that kind of leads to this outbound call again. Means this is super complicated. There are a lot of people just doing that at various vendors just to try to propagate context and also, of course, collect more information about the process that is running and the things this process is doing. So that's hard. So nothing is solved right now with just trace ID. And the interesting thing was, as trace ID was coming and customers heard about it, everyone thought, okay, trace ID exists. Now we can trace all the things. It's just magic. It will do all that. Of course it doesn't. So, and then we are in 2018, 2019. And we were pretty much done with W3C trace context. And we were already talking about, can we define a common format to exchange telemetry data? Is there a way to maybe also share how we instrument, because what you're doing basically is instrumenting and monkey patching your code to get all this information in, to start the span, to end the span when all the operations take place. So we thought, can we define something like that? And lucky enough, in this W3C trace working group, there were people, and I'm deliberately putting the people here because while this is Google or Lightstep or Microsoft or someone, it's always like really individuals that really made this happen. And I just want to humanize all the work that happened here. And there was Morgan McLean, he was product manager at Google, and Ted Young, who was basically everything at Lightstep. And Lightstep was the company of Ben Siegelman, who wrote the Dapper paper before, so now things start coming together. So Google had their way to monitor stuff in the open source library. Lightstep had their way to their open source library. And we as Dynatrace then said, what should we support? I mean, we want to do open source tracing, but now we have these two standards. And we saw then that the people started talking, and it was late 2018 in Seattle again, where there was the KubeCon, and there we Morgan and Ted told us that they will do something, they will form a project together, and this is what you now know as OpenTelemetry. So this was the inception of OpenTelemetry, and these were really still to the day. Morgan is now at Splunk, and Ted Young is still at Lightstep, but this got bought by ServiceNow. So they built OpenTelemetry together then. And yeah, also one person I want to mention is Yuri Skuru. He was the guy behind Jaeger. Who knows Jaeger? Almost everyone. So Jaeger Uber project, as I said, also very bright guy, and he was an invited expert also for the W3C group. So I can really say that W3C trace context basically very much paved the way of what we know as OpenTelemetry today. Yeah, and all that is in the Cloud Native Computing Foundations. Now we are back at this meetup because CNCLinz. So OpenTelemetry is, from its setup, pretty cool actually, because it provides a lot of integration points. So it never tried to replace observability or monitoring tools, but it provides a lot of integration points for vendors, whoever, to hook into. There is an API that is well defined. This is basically so that the user can write start span, end span. Yeah. Then there is an SDK which does the work, which does the wrapping, and when you say start span, it does actually start the span. There is a processing pipeline, and then there is an exporter. Then there is a collector where all this data is sent to, so that's a separate service usually. And from the collector, you again have an exporter and a telemetry backend. And all those, everywhere you see, where's my, yeah, I think the battery is gone. So where you see these numbers, everywhere you see this number, you can basically write your own thing. Yeah. So if you decide you want to swap out the SDK for OpenTelemetry, fine, go ahead and do it. Will be a lot of work. See you in a few years, but you can do that. But that's pretty unique. So they never tried to replace any vendor. And this is a little bit more like a zoom out picture where you also have Kubernetes for infrastructure monitoring. There you see the microservices that have the auto instrumentation in there, because that's another thing. If you, for instance, have an application and you want to see your database calls or your calls to a queue, yeah, whatever you do with subsystems, then you need auto instrumentation, because something has to do the start span, end span, or you write it yourself. But again, that's a lot of work that you want to avoid. The auto instrumentation is usually the way to go. It will see what you have. It will automatically try to wrap your stuff and do the start span, end span operations there. Yeah, you have the hotel API SDK, and yeah, the collector sits in the middle of that and sends the data out to different endpoints like time series databases, trace databases, column stores, whatever, or just a vendor. So now we are, like with everything and shiny new things, we are right now, right here, right? Everyone was super excited. We are still in 2019. OpenTelemetry was everywhere. It was not, and I will show this in a second, it was not anywhere close to anything stable or usable, but our customers already started to ask, hey, do you support OpenTelemetry? Because, I mean, obviously that solves now all the problems. Screw that. Back then, Dynatrace had around, I don't know, over 10, 12, 15 years of experience writing instrumentation, but now OpenTelemetry is here since about a week. They obviously do it better. And it happened like that. So in 2019 still, and it was in, I forget, it was in San Diego. San Diego, fall 2019, a keynote, OpenTelemetry makes observability simple. And now we are at the level of FUD, yeah? So fear and uncertainty and doubt. So Sarah Novotny, I think Microsoft at this time, and Liz Furlong-Jones of Honeycomb stand up there and said, we need new tooling and we need the ability to observe and to look inside our systems that we know what's happening under the hood. And she says, this sounds obvious, but if it's so obvious, why haven't we done it already? Because it's hard. And there I was sitting in the audience, and there were the New Relic guys, and there the more Dynatrace guys, Elastic for everyone. And we are like, what is she talking about? We did this. Yeah, we already, that problem is a solved one. Yeah, you just, fine, OpenTelemetry is great, but it's not that you're solving an unsolved problem. But again, audience was like, yeah, finally someone solves that. And yeah, because also for the audience, basically the people were sitting there, maybe observability was something new. I don't know. Yeah, no one called that really out. So what she said, finally, the problem of distributed tracing has been solved. I showed you the timeline before, right? It started like 10 years before. OpenTelemetry is the solution to all of this. And she more or less said they built this, which was also not true. And then she went on to try to show how easy it is to instrument the Go application, and it did not work. The demo just, I mean, and for that, I have to say all the kudos to Liz for that, because standing in front of, I don't know, 1,000 people and failing on a live demo she did it well. Yeah, it was really nerves of steels, and so all that was fine. But it also showed, okay, everything is not unicorns and rainbows in OpenTelemetry land. And we are still in 2019. I have to mention that. This is now 3 years before this thing even went GA. Yeah, and they tried to already sell it as if this was now done and ready for prime time. What was interesting really was OpenTelemetry picked up big time. Here you see all the companies that got involved, and here you see the contribution stats, and you see how this really took off. OpenTelemetry is today the largest CNCF project after Kubernetes. So it's definitely a lot of work went in this since, but this talk was given right here. This code was missing. Yeah. So still, and the industry reacted big time to all that. We had a lot of acquisitions. So many new vendors entered the market because, I mean, how many SDK developers are at Dynatrace? 100, 200? I don't know. Does anyone know that? A lot, right? So 200, like as a startup, you have to afford this SDK development, this monkey patching and all that. With OpenTelemetry, you could take the shortcut. And right here, you see this is the data magic quadrant that lists the observability companies, and it's very small, but a lot of companies that suddenly went into the top right corner were companies that did not have tracing at all before. Yeah, they just used, and it's fine. That's what it's made for. They used OpenTelemetry to enter the tracing market. Splunk acquired Signal Effects and then Omnition. I met the founders at KubeCon in San Diego after they were acquired, and they were very drunk. Yeah, ServiceNow acquired Lightstep. So everyone tried to get into this observability market. There was a lot of movement there. You see there are a lot of companies, and even companies where you would not expect it, like Shopify, which contributed plenty to it. So yeah, one thing I have to share is also, in previous talks, I always said how, like when I was talking for the larger vendors, how we embrace this observability and this open source spirit, and now that this is open and everything is awesome and that it's open source now, all that. I can tell you that each CTO I worked with in the observability space hates what happened here, right? Because, I mean, you spend so much time and and build your company around, and a lot of people are working on that stuff, and then suddenly all customers come to you and say, yeah, but this thing that some random on the internet wrote, this integration is way better than the SDK team that in your company does. It's hard to swallow. Yet there are a lot of merits to it, of course. I mean, it makes sense. The thing is, when each vendor, Dynatrace, New Relic, everyone writes the same instrumentation for the same library, which do basically the same thing. It's really a good thing to standardize that in some way, so that given in a time where we have new services coming up like almost every week and new frameworks coming up, especially when you're in the JavaScript space, like every day you wake up, there is a new framework. Having something that is standardized and putting the work, like combining the work, makes definitely sense. So real quick about the state of OpenTelemetry today. OpenTelemetry, and that only talked about tracing now, but it consists of tracing, metrics, and logs. Traces are GA. Metrics, which can be a replacement somewhat for Prometheus, are, at least for application metrics, they are now also coming stable. There is RC was in May. I think they are stable for some platforms already. And still experimental is logs. There again, I was somehow part of that because I was working at Elastic when we contributed the Elastic Common Schema to OpenTelemetry, so to have one common way to instrument things. Important to note is, what does OpenTelemetry not provide? So it does not provide a backend to store the data. It just emits data. It uses OTLP, which is a protocol defined by OpenTelemetry, to send the data somewhere. It does not provide analytics on top of your data. It does not give you a user interface. And also very important, it does not have proper front-end and mobile monitoring today. So this is still a little bit in the works. But what it gives you, and the first thing is the most important thing for me, is it gives library vendors, like the persons that write the MongoDB driver for Java or Node.js or whatever, or Python, it gives them the possibility to add observability hooks, observability code directly to their code. Yeah, if Dynatrace goes to MongoDB and says, "Hey, we are building our monitoring code into your driver," they will say, "No, never, will not happen." Yeah, but OpenTelemetry as a standard, it's a fine thing to do. It provides auto instrumentation for many platforms and frameworks, because yeah, there are more people that write all the integrations for all the different libraries. It gives you also important an SDK for vendor neutral manual instrumentation. What I mean with that is, and this is a common request, not everything can be solved with auto instrumentation. So very often developers want to add their own start span, end span, their own instrumentation code to the application. And it's a little bit, I would say, it does not feel good to litter your code with vendor-specific code. You're using New Relic today, so you're writing all this instrumentation code into your app, and then you switch to, I don't know, Datadog, and suddenly you have to basically change all your code to fix that. With OpenTelemetry, you basically have a unified API that you can use, a unified SDK, and you just change the, switch out the integration. It has a data format to exchange telemetry data, which is really well defined, HTTP and gRPC, and it provides a way to send data to multiple observability backends. So suddenly you're not bound anymore to using this over the other vendor, because some vendors do one thing good and the other things good. You can basically fan out telemetry data to all the backends that you want to use. That's, I think, a key statement that was from Sergey Kantsev back then at Google, now at Microsoft, I think. he said we want every platform and library to be pre-instrumented with OpenTelemetry, and we are committed to making this as easy as possible. So that's the ultimate goal of OpenTelemetry. Not that you have to build your own monitoring solution, but more to use OpenTelemetry under the hood and to just move faster when supporting new technology. Real quick, because it's interesting how we build OpenTelemetry at Sentry. So what we did was we have our very own format. We bundle stuff into so-called transactions, super complicated. So we thought, how can we support OpenTelemetry now? And it was basically a hack week project that made us support OpenTelemetry within 2 months or so for all the platforms. So what we did is we created a so-called spam processor. Also something OpenTelemetry supports. So you can basically create a processor which will basically provides a callback that gets called every time a span starts and the span ends with the payload of what just happened. And then you can do whatever with this data. And that's all we did. So we have created a spam processor. It's just really, it's not a lot of code, and using it is like 3 more lines of code for the user. And then we are just sending the transactions to Sentry. And on the additionally, of course, a customer can still send this to all the other vendors. So it's pretty cool. It was super easy to implement, and just that works because OpenTelemetry was built for exactly such use cases. I want to show you a very quick demo at the end. But before I do that, I want to show you, and Giuliano is somewhere here. Yeah, he knows that very well. So there is an OpenTelemetry demo, microservices demo, based on Hipster Shop. We have now back at Weaveworks, who created the first Hipster Shop. It's a lot of services that you can monitor, and in the end, you should get something like that in whichever system you use. But it's very cool because you have a lot of different languages, etc. It's a good playground to try out OpenTelemetry. We at Sentry have, as all the vendors, our own blend of this demo, just adding a few Sentry things to it, but you can use the official one, whatever. But it's worth giving it a try. It's just Docker containers that you can run. So pretty fun and easy. And now let's try a demo. And with that, I have to stop sharing, I guess. And I have to share a window. I mean, the most important thing I want to show you here is that this all is not pretty. So what I created was more or less, you have a browser front end, you have a backend with Express, then you have some service gateway, service green, or service blue. Service blue is failing, and then you have a MongoDB. And all those include this code. And this code that I show you here now is just the code that you need for OpenTelemetry to work. Now you know why Liz back in 2019 was so struggling to get this all right in a live coding session, because it's really hard. And you see that the important part here is this is not really made for you trying that at home for everything, right? This is more or less like a set of building blocks that you can use to build an observability system, but it's not like include OpenTelemetry, zack, there you go. Yeah, so this is just the require lines that you need to make it work. And then there you see, yeah, all the things that you have to add. This is Sentry. So you add Jaeger as a backend, you add the Sentry spam processor, you have to register providers, you have to add instrumentation. So it's pretty tough to do. Yeah. And another thing you see here, this thing is still very much in development because Jaeger just decided that they want to use the standard OpenTelemetry OTLP exporter. So this is not deprecated. So it's also a little bit of an uphill battle to stay up to date with all that stuff. But if we run that, So now switching back to browser. So I created a very complicated web app that tries to solve the problem of all problems, tabs of spaces, and you can just basically just click here, and every time you see the skulls, you run into service blue, and which causes the error here. So I'm running that here, and I'm sending the data to OpenTelemetry and to Jaeger, to Sentry in this case, and to Jaeger at the same time. So let's see what comes along in Sentry. So yeah, not everyone knows that Sentry also does performance. And there you see the events, and then you can click into that. And there, awesome. So now I have to go back. I have to start all over. No. So here you see the requests coming in. Here we have this get request. You can drill into one event here. And here you see this trace view, which is basically what we collect via this spam processor from OpenTelemetry. And there we create your what you know, this classical waterfall. One way to do it, very easy. So we basically, we take out all our auto instrumentation here. Our developers are pretty happy to not have to write this themselves anymore. So they're happy that we are using OpenTelemetry now. But you can also use Jaeger. So we are sending at the same time to Jaeger. Jaeger works like that. It understands all the services that you have. Still, yeah, again. I mean, after such a long time of video calls and COVID, I should know how to do that, but I don't. So here you are in Jaeger. You can filter by services. You can filter by different like tags or also durations of a span. Interestingly, it will also give you a not really pretty but correct service graph, yeah, because it understands the topology of the things that you're doing, which can be helpful, really. So it's just starting a Docker container and sending the data to it, and it can be helpful to understand what you're even doing in your microservice architecture. And if we go back here, let's look at, for instance, here we are calling into service blue, and this is a failure. And there you see, so this, and we are now back, we're closing the loop to the beginning, where you want to see where a problem comes from. And in this case, you would see it, that it comes from this service pool. So you can drill into that, and you can look into which traces of all the traces have an error, and then look into the service, basically into the span tree to see where this is coming from. And this is basically what you do with distributed tracing. And I think I'm done. Thank you.
Thanks for your talk. You went in great detail about how tracing works, but you've kind of glossed over metrics and logs. I would have been more interested in that.
Yeah, I was, but that was my fear, because we are at
the, just a short thing. If you contrast it with how Prometheus works, how would this work with open tracing to collect metrics?
So I think I'm not an expert for metrics, to be honest. For the most part, I worked on traces, and metrics just went GA. Richie of Prometheus is very close to the whole OpenTelemetry project, so I think there will be some way or the other where the things will come together. When I researched for this talk, I found one other talk, basically by Grafano or Prometheus at Promcom, where they really talked about how how where the differences are, because there are differences. The data format of OpenTelemetry is different. The way they interpret numbers is different. So it's basically two ways to report the same data. But I would say Prometheus, in my mind, is still very much on the infrastructure side, and not so much for application metrics. And application metrics are easier to report with OpenTelemetry, because there you also can attach the trace ID and see in which context this works. So if I did it, I would still would use the OpenTelemetry collector maybe as in between for Prometheus to send data to. They have a Prometheus ingest as far as I know, and unify the data there, but still stick to Prometheus. But as I said, no expert here.
Thank you for the talk. I wonder, it works really good for application traces and stuff like this, but sometimes you also have a bit of a technical depth, and people tended to use stored procedures and stuff like this in databases. Are there possibilities to bring this also on that level?
No,
that was my fear.
Yeah. It also gets complicated when you have fan-out scenarios, when you have batches that are running. All that is not perfectly modeled by neither distributed W3C trace context nor the model of span. It already gets complicated when you have reactive applications that are basically just evented. Does not work well. Yeah, definitely get rid of that.
Thanks, Daniel. Maybe I missed it because I stepped out for a second, but so you mentioned the whole history, and I really liked it. And when I first got in touch with the when I got in touch with the whole topic, it was still called APM. Now we are talking about observability. Was this needed for OpenTelemetry to kind of to rise, or kind of they just invented or they just named it, gave it a new name, and then they were the first ones, or like how do you now compare APM space to observability space?
I mean, I briefly explained the difference between monitoring APM and observability. I also started with APM. Now I'm doing observability. I'm still doing the same. It was pure marketing. So observability is a concept of control theory. It's basically how you can infer the state of the systems by looking at its outputs. That's the mathematical theory. And it was charity majors of Honeycomb, which in a really small company, but which in a really impressive move pushed the term observability on the market by being extremely loud about it. So she told, like, everywhere on Twitter, and she has quite a followership, she told everyone that everything that is not observability is basically shit. And if you're not doing observability, it just does not make any sense. And at this point, of course, Honeycomb is the only company doing proper observability. That was the whole story. And suddenly we found ourselves like changing our titles on the websites. Now we are doing observability now. It was one person. That's the whole story that changed the whole market.
Cool.
Right. Thanks.
Thank you very much.